Hello, it's Miss Billman. Today we're going to be talking all about surface area. Area should sound familiar because we used area a lot during Unit 2, and now we're on Unit 4 and we're looking at, 3D shapes. So when we're talking throughout Unit 4, you will notice that there are some different words or vocabulary words that you most certainly need to know. The three I'm going to point out today will be edge, face, and vertex. So I took that square that was on my paper and I've made it into a 3D shape, perhaps a cube. I do kind of feel like my drawings would be better if I had a ruler, but for our purposes, I'm not going to lose sleep over it. I'm taking my purple marker and I'm outlining that what would be like a square if I didn't add onto it a little bit darker. This is because that's our first vocab word, which is edge. I always think of like the edge of a cliff, or if there was a mesa, which, they stand tall and flat. The edge is formed when two faces meet. So like the edge of a table, it's like where the side and the top meet. You may be thinking, but Miss Billman, you haven't told us what a face is. Okay, that's right, I haven't, but I'm going to tell you right now. A face, you see, I'm getting at my blue marker. A face is the flat part of a solid. So when we're talking about faces, we see it a lot in nets, which is all throughout Unit 4. But when we're looking at originally the word face, you might think of your face on your face. I guess it's hard to say your face on your face. Okay, similar. That's a good way to remember the word, that it's that part that we can see. These pink dots, that'll be the word vertex. Vertex is different than an edge. An edge is kind of like a seam. Think like a zipper, right? It's where two faces meet. A vertex is where three corners of these faces merge together. There really are these corners that we will see a lot throughout Unit 4. You could look at a dice or a die. If you look at a pair of dice, you could see just with those tiny little cubes, they have a lot of faces, they have a lot of edges, and they have a lot of vertex. It isn't just like having one corner and calling it good. There are multiple in this case. When we go to other shapes, these words still apply. So don't worry, we're not just using them once and getting rid of them. We're definitely not doing that. But we need to keep those in mind so we're all on the same page the longer we go throughout this chapter. The greatest part about surface area is that we already know how to find area. If we're looking at a rectangle or a square, we know length times width, right? We haven't forgotten about that. But we're looking at 3D shapes. Sometimes it's hard to think in 3D, but I know we can do this together. So the surface area, this is going to be the sum. So I'm adding the sum of the areas of a solid figure. I'm going to draw a rectangle and then I will make it 3D so we can see my net that I will draw next. So when we talk sum, we'll be adding, and I'm going to add all of my areas together for each of those parts. So if I have a 3D rectangular prism, because they're all named after their bases. So I have a base that's a rectangle. And imagine that I cut it flat. Like if I was doing the best wrapping job ever and I didn't want to waste any wrapping paper. If I cut it, I would have different sizes of these rectangles. And I will be able to find the area by adding up each part. So I'm going to grab my pencil and I'm going to be labeling these. So front, that would be the front. I'm going to lightly shade it so we can see it. If I imagine it, that would be the top. Now, congruent to the top, it's the same size. They may not be touching, but it's the same size and the same measurements, is the bottom. Again, that is congruent. To the left of the front will be left. To the right of the front will be the right. And congruent to the front, yes, that's correct. It's the back. And you can see between top, front, and right, that would be a vertex. You could see front, right, and bottom. That would be a vertex. There's an edge in between front and bottom. There's an edge in between right and back. All of those words that we had just gone over. So there are really 4 steps we need to keep in mind when we're trying to find surface area. There's like this unofficial one, like take a deep breath, be calm, you're going to do this, you got this. So to start, we need to identify the faces. So I identified mine: top, front, bottom, left, right, back. And really this is for me to keep my thinking organized. Do I think that everyone needs to copy me? Well, that would be really cool, but you might find a way to organize your thinking that works for you. Now, I do hope we all come to the same answer. That would be great and make things awesome. But this is how I do it. So again, first, identify the faces. Number 2, we're going to find the area of each face. Remember, length times width in this case. Number 3, we're going to add all of the face areas. And number 4, we cannot forget, we're going to label our answer and we're going to use the correct units and they will be squared. So this actually comes from, this net comes from Unit 4, Lesson 1. I've colored it and I'm going to go through and identify each of my faces. Now this net makes a rectangular prism. The way I've colored it are the sides, or the faces, my apologies, that are congruent and they share the same measurements. So if I'm looking at it, I'm trying to figure out, okay, which one is my face, or my front, which one is the back. So if I make this pink the front, I already know the pink that is congruent to it will be the back. They have the same measurements and they will have the same area. If I go to the purple, if the front is looking right at me, the purple is the top. The congruent purple to it will be, yes, the bottom. Great answer. If I'm looking at this again, the blue will be the left and the right. This is the easiest way for me to organize my thinking and make sure I have included the areas of each part of this 3D shape. Remember, in our case, each square equals 1 centimeter. So when we're multiplying and we finally find the sum, it will be in centimeters. So I'm going to make a list for myself: top and the bottom. And I will have the front and the back and the left and the right. Each of those are the names of the faces that I have. I will also be making, if those are my rows, I will have columns of the length, the width, and I will have a column of the area. Do you remember how I would find the area for these shapes? Yes, it will be length times width. This is a great way to organize my thinking when I'm looking at going from a net to my surface area. And the more you do it, the more confident you become. I promise you'll be great. So for the top, 1, 2, 3, and that's my width. And I write 3. 1, 2, 3, 4, 5, 6, 7. 7 is my length. I multiply those together and get an area of 21. I already know if this is the dimensions for the top, I guarantee it's going to be the same for the bottom. 1, 2, 3 for my width. And it will be 7 centimeters for length. I multiply those together and I get 21. Now I'll move on to the front. My width, 1, 2, 3, 4, 5. And I go across 1, 2, 3, 4, 5, 6, 7. Did you guys notice that the top and the front, they have an edge? So their length, of course, it will be the same. The same thing goes for the back. They have an edge, so their length will be the same. And when I multiply that out to get the area, I get 35. Time for the left and the right. 1, 2, 3 as a width. And 1, 2, 3, 4, 5 as a length. That's 15. And guess what? It's the same measurements for the right. When I multiply that out, I get an area of 15. This is where I can use doubles. 21 times 2, or 21 plus 21 is 42. 35 is 70, and 15 is 30. I can make my friends of 10, or in this case, it's 100. 100 plus 42 is 142 centimeters squared. I know it seems like a lot, but the more you do it, the more confident you can become. You'll become a great mathematician.